the title that says, why are the attributes of a shape important? I want you to circle that word attributes because that's a new word to us. We want to make sure that we know what that word means. Go and use your math book, please.
It's even lines with one.
You have a math notebook in front of you. You can turn the page and see what we wrote about. That's why we wrote it down the first time. What are attributes? Mason, what are attributes? Okay. What's that?
It's something with 3 sides, 3 angles, and
So you're close. You're very similar to what Connor was thinking. Attributes do play a part in that, but that's not what an attribute is. Callie, what's an attribute? So another word for attribute might be category.
oh, category.
Oops. Categories. Ava, what's an attribute?
Properties.
Properties. We've heard that word before.
Characteristics.
Characteristics. I like to think of attributes as rules. The rules of a shape. So Mason, what you were listing, if a shape has 3 sides or 3 corners, those are examples of attributes. Different shapes have different rules. Put your hands down. A triangle has to have 3 sides, 3 corners. That is an attribute of a triangle. It's a rule. Okay. Different shapes have different rules. That's how we know that, oh, that's that shape. So even if you see something that you haven't seen before, you can figure out what category of shape it is based on the attributes. Now that we know what attributes is, let's look at that question. Why are the attributes of a shape important? Why would I need to know that? Oh, you with me?
Yeah.
Yep. Why would I need to know the attributes of a shape? Why would that be important? Tell me what you think.
Because, if there wasn't any rules or categories, properties of the shape, it wouldn't be a shape.
Okay. We need these rules and properties to call shapes. What do you think, Maverick? Why are these attributes important?
Because we probably wouldn't know what shape it is.
We wouldn't know what shape it is. It would all be blobs. Our categories help us classify our shapes, put them into certain categories. Why are the attributes of a shape important? Because fair. If you want to restate the question, you can. You're more than welcome to. In our notes, it's a little easier to kind of shorthand things, Brogan. But yes, if I was turning something in, I would not want to start with because the attributes help us. Not doing math. Help us do what? What did Maverick just say? Archer?
Know what shape it is.
Know what shape it is. They help us name the shapes. Some attributes that we can look at, go ahead and write a little subtitle under that line, attributes of shapes. Some of the things that we can look at, which we already did, we can look at the number of sides / corners. We did that on Monday. And you know that. If you see a shape that has 3 sides, 3 corners, it's likely going to end up in the triangle category. If you have a shape that has 4 sides, 4 corners, it's likely going to end up in the quadrilateral category. So looking at the sides, however many there are, is a good spot to start.
listing a circle as a shape.
So that's another attribute. Does it have straight sides? Because Brogan, if I answer that question with no, there are no straight sides, then that gives me an idea, oh, it's probably going to go in like a circle or oval category. But if it only has straight sides, is it going to go in that category?
No.
No, so that's another good clue that we can use to figure out what shape it is. Paxton. Yes. Quickly, but that should have been done earlier, not Paxton, Connor. There's one more attribute that we looked at.
Was it, has to be a close shape.
Is it closed? We looked at that idea on Monday. All of the shapes that we look at in 3rd grade will be closed, but there are shapes that aren't. You're probably it's not considered a polygon. It would be like a squiggle. A polygon is a shape. So in 3rd grade, all of our shapes will be closed. All of them. So far, so good? Today, we're going to look at another attribute. Because right now, you can very easily look at a shape and figure out if it's closed or not. You can do that easy peasy. You can also look at a shape and easy peasy see if it has straight sides. You can look at that and test. You can also look at a shape and pretty easily count the number of sides and corners. You can already do those 3 things. So today we're going to look at another attribute that mathematicians use in order to classify or name a shape.
So like, what was the name for the, she was a NASA helper.
You're talking about Katherine Johnson?
Yes.
All right. All right. Turn to the next blank page. This is the new attribute that we're learning about. It says, what does it mean to have parallel sides? That's the new title on the next blank page. Raise your hand if you ever heard of the word parallel. A couple of you. Can someone tell me where you heard the word parallel? So like in what scenario you remember hearing parallel?
Parallel.
Cool.
I remember on my diagnostic.
Oh, it said parallel on there.
Yeah.
Okay. Connor, when have you heard the word parallel?
Whenever my mom was talking about her driving test, like whenever she had the parallel board.
Oh, parallel park. Interesting. You've heard that. So, and when have you heard the word parallel?
Parallelogram.
In the word parallelogram? Anyone else heard the word parallel or parallel? Or on integral. Sure. So today we're going to explore what that word means. Go ahead and circle that word parallel. That word parallel means
Diagonal.
that's not what it means. A pair of lines. What does that word pair mean? It have 2 meanings, right? I know there's a group. We'll call it pair. What's pair I'm talking about?
No.
So I was pair mean. 2 things. So we need 2 lines. A pair of lines that if they went on for forever, they would never touch. of a tricky definition. Go ahead and write it down, and then we'll explore what it means.
Parallel things don't ever do.
So we're looking for a pair of lines that, if they went on for forever, they would never.
I know, because there would never be an ending. Parallel triangles and
I want you to trace the two blue lines underneath that, almost like you're writing two number lines. Make sure to trace the very straight lines that are already there. Yep, pink line, pink line.
Oh.
Those lines right now on your paper, they do not touch, right? But if you imagine each end going on and on and on forever and ever and ever off your notebook, would they ever run into each other?
No.
Yeah.
Yes.
Nope, they would never, not into each other.
If they went
Not-
if they went the same route around the whatever world,
These are parallel. These lines are an example of parallel lines. Yes,
does a parallel have two meanings?
not that I'm aware
I thought it meant diagonal.
of. Nope, it doesn't.
No eraser.
So we're going to do another example. This time, I want you to draw one line going like this, and then one line going like this.
Going diagonal and going straight.
One going diagonal and one going straight. Right now, are those lines touching?
No.
No, they're not. They are not touching. However, if I keep drawing these lines forever and ever and ever, will they eventually touch?
Yes.
Yeah, they will eventually run into each other. That means these lines are not parallel. What's up?
So, like, how come, like, what Connor said with parallel parking, it's still straight lines. Why is it called parallel parking? Like, something.
What do you think your car is parked parallel to? Here's Claire's car.
We gotta draw that.
Sure. And here's the curb, right?
Oh, to the curb.
Parallel parking to the curb, right? If that car went straight forever and ever and that sidewalk went straight forever and ever, would they ever run into each other?
No.
Yes. If you parallel park correctly, no.
This.
So yeah, when you hear people talking about parallel parking, that means they are trying to sit the same direction as whatever they're parking next to. And the idea is if they kept going on forever and ever, they would not match. So then, don't do that. Parallel lines around this room. All right, we are arching parallel lines around the room.
You know, like our chairs. This is parallel line.
All right, are talking about the part that you sit on. Each of those sides run parallel. Perfect. Paxton, where else are parallel lines in this room?
On the top of the smartboard.
Top to what?
Top to bottom.
Okay, so the top and bottom. Remember, parallel lines are a pair of lines, so it can't just be one. But the top and bottom of the smartboard are parallel. Perfect. Lydia, example of parallel lines.
The shelves over there, top, bottom, and the side.
Yeah, each shelf is parallel to the other shelves. And then the sides going up and down are parallel. Beautiful. Ava, example of parallel lines.
The cracks in between desks.
The cracks in between the desks are parallel. Awesome. Marley, what do you mean by that? Where are your lines?
Top
Top and bottom of my whiteboard are parallel. Archer, parallel lines in the room.
the top to bottom of the front of our
Okay, so the body of RX Alien, the top and the bottom of that middle piece is parallel. Smile, parallel lines in this room. The sides of the closet door are parallel. Callie, parallel lines in this
the
room.
top and the bottom of the book.
Top and the bottom of a book. Parallel lines. Perfect. Emma, parallel lines in this room.
The top and bottom of your whiteboard eraser.
Top and bottom of my whiteboard eraser like this.
Yeah.
Paxton, parallel lines.
Top and bottom and the sides on the book.
Yep. Top and bottom and sides of a book. Avery.
And the top, the side of the side.
Sure. Connor.
The ceiling. If you look at the lines from there to there, they'll if they keep on going straight, then they'll just keep on going forever.
Yeah, the things that hold up the ceiling, those little white
And you can
plasticky
go like
pieces.
this or like this.
I love that. Connor's noticing in the ceiling we could go parallel lines going this way or parallel lines going that way. Sure, Bowen, parallel lines in the room.
Floor, the ceiling.
The floor as a whole line and the ceiling as a whole line. Now what about over there?
Yeah.
Would that still be parallel?
Yeah.
Yeah, it's just a lower spot, just like our shelf is a little lower. Broken, parallel lines in the classroom.
Look,
Yeah. There are a ton of parallel lines. So many. And now that we've seen them, we're going to look at them in some shape. We have a shape that looks like that. We're going to pretend that it's a better drawing than that, but it looks like that. Find that shape. I want you to use your fingers, just like you did with our arms, and see, are there parallel lines? Exactly what Emma's doing, exactly what Paxton's doing, exactly what Colby was doing. Raise your hand and tell me, did you find parallel lines on that shape? Archer, you found parallel lines on the shape? Where were they? The top and the bottom. I want you to take one of your colors. And we're going to squiggle. Come on now. On the top and bottom. That blue squiggle or whatever color you use shows that those two are parallel. Are there any other parallel lines on that shape? Marley? Yeah, the sides, left and right. Get a different color. And we're going to do another squiggle. That's going to show us that that shape is parallel. Or that line is parallel. So far, so good? So, where would I put that in my t-shirt? Would I put it in the side that says parallel sides, or would I put it in the side that says not or no parallel sides? It's not a trick question. Ava, where did I put it?
Parallel sides.
Parallel sides. All right, let's look at the shape that looks like this. Find that shape. Use your fingers. All right. Find, does that shape have parallel sides? See if you can find it. If you figure it out, raise your hand. Rogan, stop talking. You don't need to talk back. Stop talking. Your friends over here trying to figure it out. I see Penelope moving her fingers up the line to see if they'll ever touch. Beautiful. All right, what do you think on that one?
It does not have parallel sides.
have parallel sides?
Right,
Find
top and bottom.
them. Where are the parallel sides on this shape? Ava,
Left and right.
absolutely not. Put your fingers on the left and right. Put your fingers right here and right here. If you move them up, will they run into each other?
Yeah.
Yes, they will. That is not parallel. Not parallel. But there are parallel lines on this sheet. Where, Cole and Brogan, knock it off. Where are the parallel lines, Connor, on this shape?
The top and the bottom.
Put your fingers on them.
Because if you move really fast.
You can go either way, and they're not going to run into each other. So you're going to take one color. I don't care what color. And we're going to do a squiggle on the top and a squiggle on the bottom. Does that shape have parallel sides?
Yes.
Yes, it only has one pair, but it does have parallel sides. Let's find the shape that looks like this. Oops, I wrote that in blue. Find that shape.
Why did you put that shape on the side that
I'm not sorting them, I'm just drawing them.
Oh.
Find that shape. I love that I see Callie using her fingers to figure out, are there parallel sides?
No.
This one looks a little tricky. Use your fingers.
There's no. It's not.
We're not having conversations with our neighbor. You're figuring out for yourself. Are there parallel sides? Raise your hand to tell me. I should see lots of hands because a lot of you were talking to your neighbor anyway. Paxton, are there parallel sides?
On the top and bottom. So this way, this going that way, this way.
So any direction, if it touches at all, either way, it's not parallel. So I'm going to explain what Paxton said. He said if it goes one way, it won't touch. But if it goes the other way, it will touch. If it touches any way, it is not parallel. So Paxton, did you find any parallel lines on this shape? No. There are no parallel lines on this shape. So we're not going to do any squiggles. What about the shape that looks like that?
Yeah.
Find that shape. Use your hands. Use your fingers. That's not the right shape.
Actually, one of them isn't.
That's not the right shape.
That's not the right shape. That's not the right shape right there.
No. That's not the right shape. No.
The one that kind of looks like a diamond. Oh, this one, the diamond one that looks like a diamond.
Maverick,
Yes.
where?
On side to side.
Side to side. Get your crayon. The sides were parallel. Either direction. It will not touch. Any other pairs of parallel sides? Go and you found some parallel sides?
Yeah, top and bottom.
The top and bottom. Use your other color. So that one had two pairs. We'll do one more together and then I'll let you do the last two by yourself. Find the shape that looks like, come on now. Looks like that. Find the shape that looks like that. Might be upside down on your paper. That's right.
It is upside down.
break. I'm looking for people using their fingers to see will those lines run into each other. Julian's got it down. I see Callie using those fingers. Colby's using his fingers. Did we find any parallel sides? Julian?
Yes.
Yes, there are parallel sides in the shape. Where were they, Julian?
Top and bottom.
Top and bottom are not parallel.
Either right and left.
Because look, right now they're not touching, you're correct. But if that line kept going, and that line kept going, they would definitely run into each other. So it's not the top and bottom. Julian, which sides is it?
Left and right.
Left and right. Get your crayon, color pencil, whatever. Go ahead and do the last two shapes that we have not done. See if you can find any parallel sides. If you do, you're going to squiggle over them. If they're not parallel, just leave them alone. So if I revisit our attributes of shapes that we wrote in our notebook, one of the other ways we can classify a shape with our attributes of shapes is by seeing if it has parallel sides. So pause your cutting, pause your gluing, flip back to this page in your notebook. Pause your cutting, pause your gluing, flip back to this page in your notebook, and we're going to add, does it have
Parallel lines.
parallel sides or lines? That's another way we can look and start classifying shapes. Once you add that, you can go back to cutting and gluing your parallel lines.
Off the dog.